Actually, here identify rotational symmetry. Okay, we want to find the rotational symmetry of all these diagrams. Okay, check the boxes of the shape that have rotational symmetry. First of all, I will check the boxes which have rotational symmetry. Like this diagram, what is rotational symmetry? I mean, if I rotate this diagram, and after rotating this diagram, you can observe the diagram, and if I rotate, I mean in this way, and after rotating, I get the same one diagram again. You can see that it's the same. And if I rotate again, and I get the same diagram again. So how much time I can rotate this diagram, and I will get the same answer, same diagram again. It's a side, and this side shift can shift on this side. So it's one line of symmetry, one rotation symmetry, and this side can be shifted at this point. So two rotational symmetry, and this one can be shifted at this point. So three rotational symmetry, and this one can come back after rotation of 360. So it has four rotational symmetry. We find that how much rotational symmetries this diagram have by rotating the diagram. And I pick a side, and I assume that this side can shift it at one place, two place, three place, or after 360 rotation back this space. So that's the reason we can say that this one has the rotation symmetry, and the order of rotation symmetry is 4. Check the box because it has a rotation symmetry, and order order of rotation symmetry is like 4. And now the next one. This diagram have 1, 2, 3, 4, 5, 6, 7, 8. 8 equal sides. So there's a reason if I observe one side like this side, so this side can shift at 8 places by rotation, and 8 place will be after 360 rotation. And now you can say that it's like a have the rotation symmetry, and the order of rotation symmetry will be 8. Check the box, and then order will be 8. And now for this one, this has rotation symmetry. I think no, it has no rotation symmetry. Why? Because if you observe this side, then this side is not equal to this side, or you have a corner at this point, and here you have a straight line. And also some lines are greater and the others are smaller. You can see that this one is smaller and this one is like greater. So that's the reason this line, this shape has no rotational symmetry. I try to find the rotational symmetry by rotating the diagram. It's my original diagram, and I turn this. Okay, then I have this diagram. Oh, I think it's rotational. You can see. Then I turn again, rotate again. When this one goes here, then this one shape, then this one shape, then this one, and this one. I think this diagram has also rotational symmetry. Normally, these sides looks not equal, but if we observe some focus, I think this one, with the help of scale, you can check that sides are equal or not. It's like some 1.4, and you can measure anyone. So anyone also have 1.4. So all sides are equal. Actually, normally it looks like it's not same, but when I measure and I observe, it looks same. So it has a rotational symmetry. And how much rotation symmetry? Like pick this side. This side can be shift in one place, two place, three place, four place, five place, six place, and again at this place seven. So it has a rotational symmetry of order seven. Okay. So I tick the box, and after tick the box, I write here the order. So order of this shape is seven. Now the next one, that is this one, but this one has different sides of length. So it has only one rotation symmetry, which can get after 360 rotation. I mean, pick one side and rotate the diagram at 360 degree. Then this side comes again at this place. So that's the reason this has rotation symmetry, and the order of rotation symmetry is one only. And now this one, for this one, like it's like a rotation symmetry. Yes, it's like a rotation symmetry. So I take it, and the order of this is like one. We can draw only. It's just like it's a line of symmetry, but I am telling that if I rotate this diagram 360 degree, then I can get the same diagram again. So there's a reason this has rotational symmetry, and the rotational symmetry is like order one. And now what about this? This arrow can place at this point after 180 rotation, and this arrow can be placed one after 180 rotation. Both arrows will interchange after 180 rotation. And also you get the same diagram after 360 rotation. And the order of this diagram will be have two. Rotations symmetry order is two. And now for this one, definitely this side can place at this place, and this place can be interchanged by the other. So it has also two order symmetry, two order rotational symmetry. Order is two. And now what about this? For this one, no, I think it's not rotation symmetry. No, this is not rotation symmetry. No. Okay. So order of it will be like zero. Order of rotation symmetry is zero, and it can be get after 360 rotation. Actually, every diagram can be rotated after rotation of 360. Okay, like this. Again, this one. Okay, so we can say that order of rotation symmetry is like one. Okay, so all diagrams have the rotation symmetries you can observe, and some diagram which cannot rotate other angles, it can rotate at 360 degree. So there's a reason it has like one order symmetry, and this diagram have how much order symmetry? It's also have one order symmetry, because it can rotate also on 180 degree angle, 360 degree angle. Okay, now we want to find draw all possible lines of symmetry in each shape. We want to find possible line of symmetry. To find a possible line of symmetry, I will draw like this one. I mean line of symmetry like a line which can divide the shape into equal parts. Like if I take the example of scale, for example, I am drawing a scale and this scale, like if I draw this line, so this line will be the line of symmetry because this line change the diagram into two equal parts. And it's also line of symmetry. The second line of symmetry. After these two line of symmetry, I think this one will be also line of symmetry. This one also line of symmetry. So two these lines and two diagonal lines. Total line of symmetry becomes like four. So in the case of scale, we have four line of symmetry. Similarly, for the other shapes, we can find the line of symmetry. Okay, and this one shape, it looks like a isosceles triangle. I mean, two sides are equal. So that's the reason it has only one line of symmetry. And the line of symmetry will be like this. Okay. You can draw the dark line also. I draw the dot line. It's like a line of symmetry. And now for the this line of symmetry represent that it convert into two equal parts. Okay. And now for the next, for this diagram, looks the diagram and try to divide the diagram into two equal parts. I think at this place, it can be converted into two equal parts. Okay. And now in the diagram number 3, like this one, it's also line of symmetry. And now this one, it's also line of symmetry. Okay. And now the next, this one, it has also one line of symmetry like this. You can see that no other line. If you draw this line, it's these are not equal parts. Okay. But this one, because these two equal parts, so it's a line of symmetry. And this one can be divided here. So it's a line of symmetry. Okay. And now the next this arrow, if you draw this one line of symmetry, no, it's these two are not equal. Both should have same. So there's a reason I will draw this one. It's like a line of symmetry. Okay. And after it, this one, it has this line of symmetry. Actually, line of symmetry should draw at place where my diagram will shift into two equal parts. We can observe by drawing this line, this shape shift into two equal parts. No other chance if I draw this one, it has different parts. Okay. And now similarly for the other, these also have different parts. So only chance to draw these shapes and these shapes have equal parts by drawing the lines. Okay. So see this. If you have any problem, you can tell me.